Alright, in this lecture we will talk about what is Big O. By definition, Big O is a language and metric we use to describe the efficiency of algorithms. Without understanding Big O notation, it's not possible to develop efficient algorithms. If you don't know when your algorithm gets faster or slower, you will struggle to judge your program performance. This concept basically gives you one way of describing how the time that takes to run your application grows as the size of input grows. So let's look at the example over here. Imagine a scenario: you have a file on your hard drive and you need to send it to your friend. And we need to send this file as fast as possible. So how should we send it? So the first thing that comes to our mind is to send it by mail, FTP, or some other source of electronic transfer. This is the correct answer if the file size is small. It is faster than to take it to your friend physically. But if the file size is really large, is it possible that it is faster to physically deliver it via plane? Yes, actually it is. 1 terabyte file could take more than 1 day to transfer it electronically. It will be much faster to just fly it across the country. If it is urgent, you might just do it. So as you can see, the delivery method is changed based on the file size. This means in the first method, in which we are sending the electronically, the time that is needed for transfer of file increases as the size of file increases. On the other hand, on the second method, the time that is needed to transfer a file to a friend does not depend on the size of file. It does not matter if you are carrying 1 terabyte file or 1 GB file, the time that is needed for flight is constant. So in computer science, this is called time complexity. It's a way of showing how the runtime of function increases as the size of input increases. So if we come back to our example of transferring file to a friend, we can easily see that in terms of time complexity, electronic transfer is increasing linearly as the file size increases. So as the file size grows, the time that is needed to send this file to a friend increases linearly. But in case of physical delivery, as the file size increases, the time remains constant. So it doesn't matter if you are taking 1 terabyte file or 1 GB file, the flight time is constant. So you can see it from this graph easily. Now there are various types of runtimes such as ON, ON squared, or ON to the power of 2. For instance, to paint an area of W meters wide and H meters high, the runtime could be described as like this, OWH. Some algorithms are faster when the input is small. However, they become slower when the input gets larger. It's very crucial that our programs run fast because they are not going to be executed in supercomputers. So if a mobile app users face slow performance from your app, they tend to quit and delete your app. So thus, a proper algorithm must be chosen for our development. And to describe the efficiency of algorithm, we need to know Big O. So hopefully you have understood what is Big O.